Second example, I'm going to simplify things a little bit by making the pool size 0 to 1. There's like 10, sometimes it's knowing trying to cube of 10 or something like that. So I'm trying to make it first simpler by making it from 0 to 1. And now assume that somebody is like going back and forth in this small pool and drops 3 coins. Okay. And then what you want to do is you want to keep track of where the middle coin landed. Okay, so now this random variable x would be like position where of the middle coin. Okay. And you would see that it's highly likely that it's closer to the center than the end, because if the middle coin is found here, that means the first coin has to be found something much to the left side that has a very small probability, right? Do you agree? Right? Nor the right. So you can kind of see that the probability distribution should be something close to 0 at the end, but it has higher probability in the middle. Now the actual math, trying to figure this out, is quite complicated. It's outside the scope of this class. There's a name for such a distribution. It's called a beta distribution. And from some theory, we know that the distribution function for this case looks like f of x equals to some number times x times 1 minus x. So indeed, it's like upside down parabola. Yeah, it's just some upside down parabola. Okay, so assuming this, we're going to be solving several problems with this one, and this is what you may be expecting in the first exam. So the questions will be like, find the value of a. Example 2, find E of x, sorry. And example 3, find V of x. These things. Okay, give me a suggestion. How can we find the value of a?
Take the derivative, set it equal to 0.
No, that's how you find the maximum value. What's like a fundamental property that any probability distribution function must satisfy?
They all add to 1.
Huh?
They all add to 1.
They all add to 1, right? Exactly. So what you need is that, so actually, in other words, if you have a function over some interval, it could be infinite interval, it doesn't matter, and it satisfies 2 conditions. One is that the value of the function is always positive, because you can't have negative probability. Okay? The value of the function is always positive, and if you integrate over the entire domain, you get a 1. That can be a probability density function for some continuous distribution. Does that make sense? Okay. Those 2 are the only requirements for being a PDF of some probability distribution. Right? Okay. So to solve example 1, what you have to do is you have to integrate ax 1 minus x from the given domain, which is 0 to 1. Okay. Let's pull the a outside because it's easier to do the integral when some constants is left out. And you're integrating x minus x squared dx. Right? If you multiply this out, it's easier to integrate after doing that. And we know the integral. This is 1/2 x squared minus 1/3 x cubed. And you're plugging in 1 and 0, multiplied by a. So what's that? That's like a times 1/2 minus 1/3 if you plug in 1. If you plug in 1, it's 1/2 minus 1/3. If you plug in 0, it's 0. Okay, so this is what you get. And if you do the computation, this is a over 6. So what's the value of a? A must be 6, because this integral has to equal to 1. Yeah. So for a over 6 to equals to 1, right, we need a to be 6, just by multiplying by 6 both sides. Okay, so we figured out the actual probability distribution. This is going to be 6. Right? Okay, now let's try the second one. Second one, you could do the calculation, or you could just be lazy and look at this and get the answer. What's the answer?
1/2.
It's very symmetric, right? So what's the answer?
1/2.
Yeah, 0.5. So you could find that if you multiply x times this probability distribution function, 6 times x times 1 minus x dx, if you do this integral from 0 to 1, it's going to be a very straightforward calculation. You could find that this is equal to 0.5. Because this is ex, right? What is ex? It's x times the f of x. You integrate over the domain. You can do the actual calculation just like how you do it in Calc 2. You get this value. But let's not go into details. It should be this one. Okay? Try to check that. All right. Now, Vx. How do you do the Vx? Yeah, you use e of x squared minus e of x squared, and then e of x, and then the entire thing squared. You subtract those two, that's Vx, right? So let's calculate e of x squared first, which is integral from 0 to 1 of x squared, 6 times x times 1 minus x. This is our PDF, right? We found that a is 6, so we just put that in here. We integrate that. That gives you integral of x squared, the expectation value of x squared. So let's pull these 6 out and just multiply x squared times x is x cubed times 1 is x cubed. X cubed times x is x to the 4th. So these are all subtracted and you integrate. That gives you 6. 1/4 x to the 4th minus 1/5 x to the 4th, x to the 5th. And when you plug in 1, 0, it gives you 1 over 20th, 6 over 20th, 3 over 10. So that's what you get. And then, therefore, v of x would be 3 over 10 minus 1/2 squared. Because this is our average, right? So that's going to be 1 over 20. I think that's right, 6 over 20, yeah, so this is a 5 over 20, and this is 6 over 20. If you subtract, that's 1 over 20. So that's how you find Vx. And on the exam, without any picture, without any context, you might be given some function. Like maybe the function is x cubed over 0 to 1, something like that. Right? And then there's some constant you have to figure out. It should be a times x cubed. What is this constant a? You just use that, figure it out. And then you have to figure out these other